Okay, now we come to electric power and sign convention. So we talk about the power of the circuit. So we have two types of power convention. Is the power generation by the equipment, and the power consumed, right? Consumed or absorbed by equipment. So some equipment supply the power, right? Generate or supply power, okay, and some equipment consume the power or absorb the power, right? Absorb the power. Okay, so this can be analyzed by positive and negative side. Okay, it depends on our system, computation system. You can make your own system, right? But there are standard systems over there, right? And the power is developed over the time. Okay, if we divide the work by the charge and multiply the charge here, right? We can get the power is equal to voltage multiplied with the current, or P equal to V into I. Okay, P is V into I. And the electric power generated by an active element, okay, or that dissipated or stored by passive element is equal to the product of voltage across the element, right, and the current flow to it. And then we use positive and negative to define that the element is generate or consume the power, right? So if the voltage in this position, right, plus and minus here, and the current flow from positive terminal, we define as positive here. So the power generated by this equipment, P generated by this equipment equal to V into I, is in positive side. Okay. This means this equipment generates power. On the other hand, if this equipment consume the power, right? Consume the power. If this is a positive side here, and the current flow into the positive here, right? Which means that is dissipated by P. Dissipate. Dissipate means consume. Okay, dissipate. Okay, and equal to V I. Consumed by this amount. Or on the other hand, if we consider this equipment to dissipate the power, okay, to dissipate the power, the sign is become negative. Okay. It means that it consumes the negative value. Consume negative value means generate the power, right? Generate this power. Okay. Similarly, for the passive element, if it generate the negative power, what we mean by generate the negative power? This means that this element consuming the power, right? In fact, it's consuming the power. Okay. So this is what I taught. Okay. Is it important to realize that just like when the power is sign quantity, it is necessary to make a distinction between positive and negative power. And then the polarity of the voltage across circuit A and the direction of current to indicate that the circuit is doing work in moving the charge, right? Moving the charge from low potential to high potential. So this is active element, right? On the other hand, in the circuit B, right, is the dissipating energy, because the direction of the current indicates the charge is in displays from the high potential to low potential. Right? So circuit A is active element, circuit B is passive element. So to avoid confusion, in the negative side of the power, the electrical engineer community uniformly adopt passive sign convention. We usually use passive sign, which simply states the power dissipated by the load is a positive quantity. The power of the load. Right? Another way of phrasing the same concept is to state that the current flow from higher to lower voltage, the power is dissipated and will be positive quantity. So use passive sign convention to this circuit. The known quantity is the voltage across each element. The power dissipated or generated by each element. We see that the voltage drop across load 1 is 8 volt, right? Here is 8 volt. And load 2 is 4 volt. And here load is positive here. Minus here, right? And the current is 0.1 amp. The current flow is 0.1 ampere. Assume clockwise direction of current flow. Actually, our polarity voltage cross flow here. 8 volt and 4 volt. And the current is 0.1 amp. Okay, if we compute the power dissipated by each element and the current flow from negative to positive to the battery here, right? The battery here. Then the power dissipated by this element will be negative quantity. The power dissipated is negative. Is mean by the power dissipated is negative. It means it's generated, right? It's generated power now. Yeah. Then the power of load 1 and load 2 we can compute it as 0.8 watt and 0.4 watt. Okay, it's positive, right? This means it is consuming power, right? Now consuming power. Similar computation, translation. Similar method. Okay, let's see this example. For this circuit shown in figure 2.25. The current flow element D and E is here, right? 3 amp. E, where is E is 10 volt. Right? The known quantity is the current through element D and E, voltage across B, C, okay? B, C. Okay. Then find which components are absorbing power and which are supplying power. So in this case, so which is the battery effect? On that is what? Which one is the resistor? So in this case, we solve for unknown value first, right? By KCL. Right? The current through element B is 5 amp. Here. We know this is 3 amp, we know this is 2 amp. So this is 5 amp in this direction, right? This is 2 amp, this is 3 amp, we know 5 amp here, right? And by KVL, we can solve for VA here. If we define the power at the current flow like this, right? This would be VA plus minus, right? This is plus minus, yeah, okay. And this is, what is D? Plus minus, right? Here is 10 volt. This is 10 volt also. The voltage across E is 10 volt, across D is also 10 volt, right? Then we have VA minus 3, right? Minus VA minus 3 plus 10 volt and plus 5 volt, right? Minus VA minus 3 volt plus 10 volt plus 5 volt. Okay. Again, be careful for the sign, right? The sign. But I usually find that it's always mistake when you do the exam. Okay? Just do many exercise to avoid that. Okay? Then we get VA for 12 volt, right? VA here for 12 volt. Okay, now let's see which element are supplying power and which element are absorbing the power. Right? So for element A, right, the current flow here for 5 amp and the voltage in this polarity, right? We can see that A is supplying, right? A is supplying power, right? Yeah. B also supplying power because the current flow out from the positive, right? The positive terminal, right? How about D? D and C is absorbing power, right? C also absorbing power because the current flow here 3 amp and 2 amp and current flow to element C. This is 5 amp also, right? 5 amp. So we can get this solution, right? So now we know that A and B is maybe battery, right? A and B is battery, right? C, D, E is below, right? C and D and E is below. With the sign convention, we can know that the equipment is now consuming power or supplying power, right? Okay. And to check your understanding, right? This slide I left you to check your understanding here. So do it by yourself, okay? After class, right? At your room. Okay, anyhow. And if you have questions, you can ask next time, right? And this is the answer. The answer is try to do stuff yourself. Okay, then come to the resistance and Ohm laws. Right? Resistance and Ohm law. I think you know well about Ohm laws, right? So I will go a bit fast, right? Ohm law states that V equal to I into R. Okay. So it depends on the element property, right? The element property. Each element will have its own resistance. It's depending on the resistivity. It depends on the material, right? And it depends on the cross-section area, and it depends on the range, right? All elements always have the resistance, okay? The resistance, right? And this is the relation between voltage and current across, right? If we increase the voltage, the current will increase, right? On the other hand, if we increase the current, the voltage across the element will increase also, right? The relation between voltage and current and is equal to L over the conductivity into A, right? Sigma. We have resistivity, right? We have resistivity equal to 1 over conductivity, right? It's the inverse parameter variable. So R is L over sigma A or rho L over A. Maybe we're familiar with this before, right? R is rho L over A, right? Resistivity. Okay, it is often convenient to define the conductance. Conductance is the inverse of resistance, right? The unit of conductance is in Siemens or mole. The unit of resistance is in ohm, right? And we sometimes use this the omega symbol. And the conductance is the unit in Siemens, S or mole. Or sometimes we just upside down the omega symbol. Yeah. So G is the conductivity is equal to 1 by R. This is an example of resistivity of the common material, right? Aluminum, copper, gold, nickel. And this is the material which we incandescent lamp, okay. The ion, right? Heater, this is a incandescent lamp inside is the resistance. Okay, and we let the current flow through the resistance. And this generator, what is generator? Heat, right? It's also a generator heat. I square R, right? It's heat, and then this become light. And this is also heat by I square R, right? This is also the heater by I square R. Dissipate the power into heat. Okay, this is that. So I skip this part because we do it in the other thing. Okay, to read the common code of the resistor is standard code of the resistor. Okay. In addition to the resistance equal the maximum allowed voltage. Power is V into I. And we know that V is IR. Then we get I square as a result. Or we can substitute I by V over R. Then we get V squared divided by R as the power dissipated by the resistor. Okay, by the resistor. That can be connected to the independent of existing resistors. 1 over 1 hour to select the resistor size, right? When we connect it to the battery, okay. Here, the quantity that we know is the resistor. The rated of the resistor is 0.25 watt or 1/4 watt, right? It means that the resistor, if the power is more than 0.5 watt when supply the current. If the power is more than 0.25 watt, it will burn down. Okay, it will damage, right? It means the rated of the equipment. If we say about the equipment rating or rated, it can withstand for amount of what, right? If the battery voltage 1.5 and 3 volt, okay, the smallest size 1/4 watt resistor can be connected to each battery, right? How many volt? Okay, if we connect the resistor to 1.5 volt, okay, the power will be V squared by R, right? V squared by R. So V squared by R not greater than 0.25, and we know that V is 1.5 squared by R, not greater than 0.25. So we can compute the resistance value, right? The minimum resistance value must be equal to, in this case, it must be equal to 9 ohm, right? This is 9 ohm. So if we connect the resistance of 9 ohm into the battery with the voltage of 2.5 volt, the current flow through this resistor will generate the power not more than 0.5 watt, right? And it will not burn out, right? If the resistor, we have this link in the resistor, right? The resistor, right? So we need to consider about the current, maximum current flow, right, to each equipment. Then if we connect the battery of 3 volt to the resistor, and also the resistor will have the same rate, okay, power rating. If we have same power rating, so in this case 3 squared by R must not greater than 0.25, okay, then R must be not less than 36 ohm, okay. This will not burn, right? So if we have the resistor with the rated of 0.4, right, 1/4, 0.25 watt, we connect into 1.5 volt, so the resistance must not less than 9 ohm, right? Otherwise you burn. Otherwise, if you would like to connect the resistor smaller than 9 ohm, what should you do? You need to select the higher, right? The higher rate, the higher one, the bigger one, right? 2 watt, for example. Okay, you need to choose the bigger one. Okay. Okay. And this is for checking your understanding by yourself. So please go to this slide, okay? And if you have problem and you have question, you can ask me next time, okay? Okay, now we come to the resistance connection. Right? We have series resistor and the voltage divider rule, and we have parallel resistor and current divider rule. Okay. So we can connect the resistor in series. Series means that the current flow are the same. The current flow through the element are the same. Right? We connect in series here. Right? And the voltage across will divide into each other. Right? If you connect the resistance in series, like this circuit, right? The voltage across each resistor, it will be divided to each other, right? What if for example, we supply 1.5 volt to this circuit, right? R1, R2, R3 will share the voltage to each other. But the current are the same, right? The current flow to R1, R2, R3. The current are same, right? They got the same current, right? Okay. Yeah. Then the total resistance equal to R1 plus R2 plus R3. Here, this is the total resistance. Okay. I think you have learned about this computation. Okay. But we have the current dividing rule. Current dividing rule said that the voltage across R1, the voltage across R1, V1 will equal to V total. I say this is Vs, okay? Vs for general. Vs multiplied with R1 divided by R1 plus R2 plus R3. This is the voltage dividing rule. Okay, and V2 is Vs into R2 divided by R1 plus R2 plus R3. V3 is Vs multiply R3, R1 plus R2 plus R3, or this is R EQ or R total, right? This is R total. For example, if we have maybe this 10 volt, two ohm, 4 ohm. Maybe 6 ohm. This is maybe 34 volt. Okay. We can compute for the voltage across V of 2 ohm, V of 4 ohm. Maybe I make it V. This is R1, R2, R3, V1, V2, V3. You can solve this circuit, it's not difficult, but if we would like to know, for example, I would like to know V2 directly, V1, V2, V3. V1 can be computed by 24 into R1, 2 ohm divided by 2 plus 4 plus 6. This is the voltage division. We can compute V1 directly. Okay? And it is, what is the voltage? This would be 24, 2 and 12, right? is 4 volt, we can get V1 4 volt directly, okay, without solving the circuit, right? We can just apply voltage divider rule to this circuit, right? And how about V2? V2 will be 24 into V2 is here 4 ohm divided by 2 plus 4 plus 6, okay, and it is 8 volt, right? We have 8 volt. How about V3? It will be 24 into 6 divided by 2 plus 4 plus 6, right? And it is 12 volt, right? We have this 12 volt, right? Another way to solve for the voltage across this resistance is you combine all resistance together, right? Usually what you do, you combine all resistance together and you compute the current, right? Total current flow, right? And then you multiply the current with the resistance, right? You will get the voltage V1 V2. But with this method, you can get the voltage across each element directly by using voltage divider rule. We call this rule as voltage divider rule, right? Voltage divider rule. It's useful for many computation. Okay. What's next? Okay, this is the voltage divider rule. General form. You can solve for any RA, right? The voltage across any resistance you can think of, right? If you want to know. But we need to know the total voltage across the total series circuit, right? Total series circuit. This is an example of voltage divider. Difficult, right? You want to get V1, V2, V3, right? With this circuit, right? Yes. R1 is 10 ohm, R2 is 6 ohm, R3 is 8 ohm, right? Like this. I think this example you can go through by yourself, right? I just make it clear. Okay, no problem. Okay, we have voltage divider rule. We also have current divider rule for the parallel circuit. For parallel resistor, the parallel means each element share the current, okay, share the total current flow, but the voltage are the same, right? Have the same voltage, okay. The element have the same voltage here, okay, and the total resistance is computed by 1 divided by EQ or R total, right? REQ is equal to the summation of 1 over by N, right? N equal 1 to N. Summation of the inverse value of the resistance. Then we have the current divider by this value, by this equation. For example, if we have the current source, right? Maybe 10 amp. 2 ohm, 4 ohm, 6 ohm. The current flow here is 10 amp, and this is I1, this is I2, this is I3. We can compute I1 by 10 amp into 1 by 2 divided by 1 by 2 plus 1 by 4 plus 1 by 6. Okay, here this is the current divider rule. Okay. And we can compute I2 in similar way. I2 is 10 into 1 by 4 ohm divided by 1 by 2 plus 1 by 4 plus 1 by 6, right? And also we can compute I3 by 10 and 1 over 6, 1 over 2 plus 1 over 4 plus 1 over 6. We can compute I1, I2, I3 directly, right? Directly without solving but the total resistance, right? We don't need to merge the resistance and compute the voltage, right? You're familiar with, if you face this circuit, you solve for total first, right? And you get total voltage, right? Then you get the voltage across every resistance. You just compute I1, I2, I3, right? But with this rule, you can compute I1, I2, I3 directly. Okay? We call this rule as current divider. Yeah. So this is also one important rule for solving the circuit. Okay? For solving the circuit. Okay. Then I think this example also you can go through by yourself again, right? It's not difficult yet. Slide. So this example we can compute I1, I2, I3. Right? This is IS, right? IS is 4 amp. Yeah. 4 amp, right? And we know R1, R2, R3, right? So you can solve for I1, I2, I3. I think it's problem for you, right? Okay. Any question? Yeah. Then this example, we have both series and parallel circuit, right? We have parallel element and we have series circuit, right? So again, this circuit is still not difficult for you, right? We can compute for the elements in parallel, right? Yeah. And R1 and R2 parallel to R3, right? Yeah. Then we add R1 and this value together. We can apply voltage divider rule to this circuit also, because we across this terminal, right? These two terminals, V across R2 can be computed by, for example, if this is let's say RA, right? This is become RA, then we can compute V by Vs into RA divided by R1 plus RA, right? By applying voltage divider in this circuit. And then we can compute, also we can compute the current flow. I is Vs divided by R1 plus RA, right? Like this. This is RA. This is RA, right? And if the source is current source, is maybe for some example, if you have the current source. 10 amp. We have this is 5 ohm, for example, and this is 6 ohm. This is 4 ohm. 10 amp will flow here. Then you can compute the current flow I1 and I2 by using current divider, right? So if this is a current source, you can use current divider to compute I1 and I2. Then you can know that what is the voltage across this, right? Okay, this is also another method, right? Okay, this is to check your understanding. Okay. I think I will stop here and we'll come to this topic for next class, right? This topic. Okay. This is all for today. So many slides for check your understanding. Okay. It's good to try and make understanding because the understanding is not because of me, but it's because of you, right? To understand something, it's depend on yourself, right? It's more important. But try to make. If you have question, you can ask. Okay, any question?